All right. Hello, everybody. Thank you very much for joining the Spring 2026 Victor short course. It's a pleasure to have you. So my name is Sylvain Charbonnier. I'm co-leading this short course with a team from the Victor project. So I'm based at the University of South Florida, and I'm an associate professor in volcanology. And I'm also a co-PI in the Victor project. So we're going to briefly introduce the other person from the Victor team. So our main leader is Einat Lev. So you can introduce yourself, Einat.
Yes, hi everybody. My name is Einat, and I'm a volcanologist at Columbia University in New York, and the lead PI for the Victor project over the last 3 years. And yeah, I'm really excited to see all of you here, and hope you'll learn as much as you want.
All right, thanks. And then we have our software engineer, Sam. Sam, you want to introduce yourself?
Absolutely. Hi, so I'm Sam Krasnov. I have been a software engineer on Victor for about the past 3 years. So I guess if you have any questions about the platform that we don't answer in these first few courses, please let me know. I'll put my email somewhere, or you can email us and I'll probably be the one to respond.
Cool. Thanks. And then we have our education coordinator, Sophia. You want to introduce yourself?
Hi, I'm Sophia. I'm the education coordinator based at Columbia. And yeah, if you have any feedback or thoughts as the course goes on, I would be a great person to reach out to. And I'm new, so I'm excited to be here and be learning.
All right, thanks. And then we have two other person in the team that will not probably be able to join. One is Chuck Connor, he's also at USF with me, also co-PI on the project, and Abani Patra, who is at Tufts University, and also a co-PI on this project. So thanks again for joining this course. So we're going to meet every Friday at 11 a.m. Eastern US time. We're also going to record all these meetings for everybody who cannot join us live. We're going to share the recording soon after each class. So anybody that cannot join can watch the recordings and do the activities that we're going to do together. So we're also going to have some office hours. So we're still planning that. I think it's going to start next week. It's going to be a separate link on Zoom, so we're going to share that to everybody. And these office hours are really there for you to come and ask any questions you want to any of us about Victor, and it could be related to that class that we're doing, or it can be related to any other topic, your research, for example, etc. So feel free to use these office hours to come and discuss with any member of our team. So we're going to give you more information on that. We're also going to use a Slack channel. So I shared the link in my last email. So make sure you join the Slack channel. We're going to communicate on that Slack channel outside of the class meetings and office hours. And so the Slack channel is going to be there for everybody to ask questions, put some comments on any activities we're going to do. It's really a good way for the participants to communicate between each other, help each other if some of you guys have some issues to do some of the activities. So it's really there for communicating not only with us but also between you guys, all the participants. So we're going to start with before I forget, we also have a pre-course survey. If you guys want to fill that up, I sent the link on my last email. Maybe Sophia, if you can put the link on the chat as well to that survey, that's really going to help us a little bit better to know you and to tailor the course towards your interest a little bit more. So if you could fill that up whenever you have a little bit of time, that would be great. So what we want to do today is really to just introduce you to the Victor platform and give you some information about what is Victor and what do we have right now in terms of resources on the Victor platform and how you can log in to use these resources. And then finally, we're going to show you some example workflows using Jupyter notebooks that you can use to train yourself in using these Jupyter notebooks on the platform. So I think Einat, you wanted to show us a short presentation about what is Victor and what are the main goals of the project.
Yeah, I'll just get started. Let me see if you can see my presentation. Oh. Sorry. It worked earlier.
Yeah, we could see your screen for like 2 seconds.
Okay, let's just do the whole screen. And can you see this now?
Yeah.
My slides. Okay, great. Okay, so hi everybody. Wanted to introduce you to Victor. So just in case you're wondering, Victor stands for the Volcanology Infrastructure for Computational Tools and Resources. And in its core, it's a cloud-based platform for volcanologists to find, use, and integrate numerical models and other computational tools such as data access and data processing. And the main goals for the project from the day one were to make it easier for people to run numerical models and broaden model literacy, so people, even if they're not modelers themselves, understand what's involved in modeling and learn to appreciate the pros and cons. And in general, the down the line is to reduce volcanic hazards by making models and data processing tools more accessible to everyone. It's following some other similar efforts in other disciplines within earth science, such as the CSDMS for surface dynamics, Scoped for seismology, Enki for petrology, Pangeo for oceanography, and OpenSARLab for INSAR processing. The team is myself and Sam. Sorry, this was a recent change. Instead of Amelia, now we have Sophia here at Columbia, and then across PIs Sylvain and Chuck and Abani at South Florida and Tufts. We also have an advisory committee, which includes people from other universities and other institutions, such as NASA and other universities around the world. And we have a website that this is our kind of domain is victorproject.org. If you go to the website, you have that's the easiest way to get access to our hub, which is that cloud-based platform, which is based on a Jupyter Hub technology. And inside it is a library of models with dozens of models by now. Also some fundamental tools such as GIS or libraries or compilers for different programming languages, and access to external data sources such as NASA, Open Topography, and other resources. And then all of these are integrated through workflows, which are based on Jupyter notebooks, which we'll show you examples later. Some of them are tool specific, one notebook per one tool. Some of them integrate multiple tools to create a workflow. Also on our website, you'll see updated list of events as well as past events, but sometimes there'll be recordings, people who are involved and collaborators, a very active education page that has teaching content such as slides and lab assignments, as well as links to many recordings and manuals and tutorials that are on our YouTube channel. last on our website is the way to sign up, authentication that you've hopefully all gone through by now, based on either GitHub, Microsoft, or Google accounts. And there's the link to our documentation and communication channels through Slack or through Read the Docs. Here's a list, and that's already out of date with all the different individual tools that we have for the wide range of volcanic processes, such as lava flows, pyroclastic density currents, ash dispersal, tuff dispersal gas, lahar, slope stability, and what have really been expanding recently is tools for volatile degassing. We have 4 or 5 tools now, as well as tools for petrology, thermodynamics, and mineralogy calculations. Not listed here are workflows that are related to remote sensing, which have also been added. And there's new tools coming all the time, so you want to stay tuned. So technical view, the hub is used to run Ubuntu 22. It's now being updated to Ubuntu 24, and it's fully featured with C, C++, Fortran compilers, JavaScript, Python, R. Like, so we also support MATLAB, even though we downplay it a little because it doesn't comply with our open software principles. But we know a lot of people want to use it. There's a variety of Python packages for machine learning, image recognition, remote storage, mathematical calculations, and everything in between. And everything is hosted on the AWS, Amazon Web Services, cloud services. So after you sign up, you would want to log in, and that would be your login screen. You can get to it either directly or through our main website. When you log in, it will ask you what kind of server you need. This might be a little different now because now we also support GPU. So you choose depending on if you need a lot of memory or not a lot of memory for your calculation. And then when you log in, you'll see the Launchpad main screen, which would look something like that. With the first time you'll log in, there'll be just a couple of folders here. This is my screen, which also already had like all possible folders. On the Launchpad, there's the icon to launch a virtual desktop, which is kind of a nice GUI based, like a Windows or your laptop. There's also a click to open a terminal, so command line options. And what you'll see as you log in, you'll see a shared folder. And in that shared folder, there's going to be a lot of our pre-installed models and tools and Jupyter notebooks. For example, here's a notebook. If you haven't seen one before, it's code that has both code cells, this is a cell, as well as cells that are called Markdown, where you have just explanations and of what is happening. So this, for example, is a workflow that runs a lava flow model called IMAX, and it starts usually with importing the necessary libraries, and then go, calculate, do the parameters, everything you need, and most workflows end with some sort of visualization of the results. Like I said, is a virtual desktop, and it looks something like that, and that to allow tools such as a web browser, if you need to access, for example, an external database, and QGIS, which is open source mapping tool. For example, here, taking those lava flow simulation results and plotting it on a Google Earth background with in QGIS. So what we really like about Victor is that it not only make it easy to access specific models, but now that everything is on one place, we can do integration of multiple tools. For example, if we want to compare or benchmark tools that do the same thing, to make sure that what the similarities and differences would be. So for example, if we want to test a lava flow simulation of all the available tools, you would put in the shared information, such as where the vent is and what the topography is, and set up the specific parameters for each of the models, and then compare them. For example, here we ran 3 lava flow models on an ideal case with just a spreading drop, and on a test case on an eruption from Hawaii. Also, we have access to data through, for example, remote sensing workflows. This one is based on the NASA Opera project, which makes high-level processed data accessible. And we're looking, for example, to identify this lava flow in Iceland. We're working on a lot of workflows for inversions. So you'd, for example, input observations of maybe tephra deposit thicknesses, and then invert for what the eruption parameters must have been, such as plume heights and eruption volume. In the future, we're planning to use the fact that all these models and tools and data are all in one place and speak the same language to couple models, for example, magma chamber evolution model to conduit ascent model to plume and ash models. Also to geophysics, such as ground deformation models. This is just a snapshot of some of the tutorials we have available through our YouTube channel, Volcano Cyber. There's an introduction. There's specific for general ideas like Python and Jupyter Hub. You can find them there, as well as for specific tools and content for education, such as labs and slides. We do a lot of events. This class, one of our key events, but we also go to workshops and conferences and have tutorials. So if you wanted to meet in person, sometimes we'll run a small workshop at, for example, AGU, EGU, and IFC. We hold a developer summit where people who developed their own tools come together and make them available to a much broader audience than they would if it just stayed on their GitHub or website. This is some pictures from that workshop. So yeah, that's just a very broad introduction to Victor, and I'm sure we'll go much more into details now that as we go through the class.
Thanks, Renat. So before we all go and log into Victor and explore a bit more the hub, is there any questions so far on it? That was a little bit fast, but it was just to give you an overview of what is Victor and what the main goals are here. I think you guys have seen that it's a community-based project, so it entirely rely on the community, and that's why we want people to use it. We want you guys to use it, and so it's very important that you feel familiar with the hub. So at the beginning it can be a little bit intimidating, on just like going on the hub and see all these things and not really finding what you want. So that's why this course is here for you to learn more. And I guess, since we're going to get started with using the hub, you're going to get more familiar with the tools and being able to make your own studies and work. So, but is there any questions so far before we start digging into the functionalities of the hub itself?
Not yet.
Okay. All right. So Sam, you want to take over and show some of the hub functionalities and the organization of the hub?
Sure. Do you want me to start from logging in or just share?
Sure. Yeah, if you can start with logging in case people still have some issues with that.
Okay, let me see if I can do this nicely. One moment. Okay. Okay. I'm sorry, I'm trying to figure out how to do the whole screen.
Okay.
Okay. Um,
Yeah, we can see your
And-
screen. Yeah.
can you see this right now?
Yep.
The server options? Okay, great. So just to save a little time, I won't go from before you've logged in, but we'll assume that you have access to Victor and you've gotten in. So, and 99 times out of 100, we will say pick this option, this image, and then
Wait,
one of these.
we're only seeing the Teams page right now.
All right. Okay. Let me try that again then. Okay, now?
Yep.
Okay. Yeah, for some reason, it seems that there's not an option to share your entire screen. Okay. So, as I was saying, we'll assume you've already logged in and have access, but most of the time, all you'll need is this CPU only, using the Victor Notebook image, and then one of these first two options. So I had a 7 GB option. This one will give us a little extra room.
Can you give it a bit more detail on like when shall we use one option preferred to the others?
Sure.
What are they for?
So if you're running any of the notebooks we'll run today or next week, you only need those smaller options. A lot of the time, the reason you would need more processors or more memory are for heavier models or if you are streaming a lot of data. So for instance, a lot of the remote sensing processes, we recommend using the larger machines because you're getting dozens of gigabytes of data of satellite imagery. And we'll show that, I think, like about halfway through the course. So you'll be able to see that as well. Okay, so I had this machine preloaded, but sometimes it can take up to a few minutes, but you can see in that kind of loading bar before, it'll tell you exactly what's happening. And most of the time it's just basically taking the image, which we have in what's called a container. It's just kind of this nice, nicely packaged machine or like configuration that you, in theory, could use on your own if you wanted to figure that out. But it pulls that information and sets it up on our cloud computing. So
I think if you have any trouble logging in, can you please put your name in the chat, and then we can get back to you and see what's going on. Okay, we don't really have time to do that during that hour, but then we want to make sure everybody can log in to the platform. So if you have any trouble logging in, put your name on the chat, and then we can get in contact through the Slack channel or through the office hours later on, just to make sure that you all have access to the hub.
Okay. Right. So now you see all of these things. You at the beginning, you should only have these three that I've highlighted. Where we're going to look is in this shared folder right here. This is just for admins, so don't worry about that. So if I go in here, we have a couple things we can look at to start. We have a DEMs folder, which right now serves as a location for kind of common DEMs that we've used a lot of. So we have things like Mauna Loa. I think we have an Etna DEM. They're not specialized in any way, but we just try to have kind of a convenient place for people to access them. We have Kaliva, yeah, you can see here, some from Iceland. What we'll be using primarily in this course for, or where you'll be looking is in this education section. We have all of the workshops, courses, and so on that we've done over the past few years. So you're welcome to look inside any of these, but if I pull this out, you'll see we have the USF CompVolk Spring 2026. That's this course. I'll come back to this in about 5-10 minutes. But yeah, if you're interested in any of this content, feel free to take a look, and it should be fairly well explained and structured within the context. For the most part, you can ignore libraries. That's some internal work we have. This is where we have some things like Julia and MATLAB installed, and then a few extra libraries like PyVictor or Victor.py, which is just some helper functions, which we'll talk about, I think, next lesson. The kind of meat and what we'll be focusing on a lot over most of the course is the models folder or the models section. So you can see here, I have not done a head count recently, but there's probably nearly 50 different models at this point. And they range from alpha melts, which is, a melts focused code, to hash dispersal, to some GNSS, to PDC, to lava flows, and I think Sylvan has sent out the syllabus. You can see all the different things we have, and pretty much all of them are within this folder, the source code and all. And if you really want to look into them, you can. We can pick one. You can see all the C code you want if you really want to, but we will take a step back from that for now. So going back, up. We have a folder for Opera, which has some of our remote sensing code. Again, this will have its own lesson, but if you're interested, you can absolutely look in there. And then I'll scripts we can pass over now, because everything there is just helper code to make everything else run smoothly. But workflows is the other key place that I want to highlight. So what we have in here is a non-exhaustive list of Jupyter notebooks for many of those codes that I showed you in that models folder. Some of them, for whatever reason, are either too complex or to have too wide a scope, or maybe use a GUI or have like a web interface rather than on the command lines, so it's harder for them to interface properly. But we still have maybe 35 different notebooks for benchmark, for remote sensing, and then for all of these individual for all of these individual models. And I can open any given one here, and again, we'll get more into this later, but you can see we try to step you through saying we're going to actually create the pyroclastic flow. We're specifying where the DEM is, where the actual flow will start, and then kind of run through it, set some other parameters. Again, I won't dig too deep into it right now, but this is just one of many options we have. What I'll say now, if it's good with you, Sylvan, is I did put some of the intro notebooks in from previous years in here that people can try to run if they're interested. But if you want me to highlight anything else before that, or you want to leave this to next session, I'm also happy to do that.
Yeah, sorry, I was also busy in the chat. Did you talk about the terminal and how you can install a model via the Victor setup command?
Sure, absolutely. We can do that right now. So we have in the terminal a command called Victor setup. It's Victor, the name of the platform, space setup. And right now we have 21 models configured for that. And let's say I want, I don't know, let's do disk S. So we say 3, and it will, if you give it 5 seconds, you'll see on the left pop up disk S. So we have this command line tool to basically set up everything for you. You don't need to copy and paste files. We don't need to have to go and figure that out. We have this, so you set it up, and really all you need to do is open that notebook and then start going through, and then so on. I mean, I can run this all the way through, but we'll also spend time on this later. If I just do this, you can see we have a couple different commands to verify and update. We have a Victor benchmark command. This is just part of our, one of the many tools we have. All right, so on anything else?
Not that I think of now, but maybe can you briefly introduce the structure of a Jupyter notebook for those who are not familiar with?
Absolutely. I will use one of those because they are very well structured. But so for now, I'm going to copy this and put it in my home directory. But okay, so we open a notebook and we immediately get some kind of nicely formatted text. We have this header, so using Victor to solve volcano science problems, and we're just trying to provide introduction. Yeah, and this notebook is actually a great example on usage. Everything is written into a cell. The big thing about these notebooks is that they have a memory. A lot of the time you run code, you give it parameters, and once it runs, and once it's done running, it forgets everything. But what we have here is each cell kind of has its own memory, so we can run this and then say, okay, what is and it still remembers it even though it's a different cell. In a normal Python file, you try to print this out after you've run, and it would say, what do you mean City Center North doesn't exist? But now we have this like perpetuation. So yeah, but the nice thing about these notebooks is that we can interleave between an example saying, here's, we prompt, suppose a GPS gives the coordinates near the center of the city of Pasto. How far is the crater? And then we can do we just do a little bit of math right here. And then kind of keep going. This notebook has some kind of prompted questions that we had users fill in previously, but you can see additionally that you also can do like LaTeX or like well-formatted math or like formula formatting. So there's that option there. And I'm trying to see if there's anything else. Not that I can see particularly, but you can see even just in this notebook, which is doing a couple quick, simple math calculations. At most, we're doing some trigonometry. Everything is kind of nicely packaged in there.
So the great thing with Jupyter Notebooks is that you can really structure it the way you want, right? So you can either open a notebook that is already been created for you, or you can create your own. And when you create your own, you can really start, using the different cells to put some text, some equations, or you really want to do, some coding in there. So you want to put some command lines and some functions and things like that. So the idea is really to have something that is modular. So then once you create it, if you want to change it, you don't have to redo the whole thing. You can just go to the cell that you want to change and put some edits and change things. And the great thing is also that whether it's text, whether it's figure, whether it's codes, lines of codes, everything can be in the same page if you want, in the same notebook. And so it makes it very easy to use codes, for example, because you can have one cell, for all the libraries you want to import to make the code work, and then you have all the inputs that you need for your code. Then you have all the cells that are going to run the code, and then finally all the cells that are going to show you the output of the code. So the organization is really made make it modular enough so that you can really play with that and change it the way you like.
Absolutely. I just wanted to highlight, like, this is an example of just having a figure, right in the notebook. There's even packages to make kind of interactive, to make interactive graphs on maps. Let me see if this is still active. All right, I'll try to find this later, but there's just a huge array of tools and capabilities that are even just within the notebook. And if you're willing to step a little bit outside the notebook, there's even more. We have all these GDAL tools, and then is it underscore? Yeah, so if you're familiar with any of those commands, that's all installed here too. Oh, and then what I also forgot to mention is that there is, we have this virtual desktop. So if you really want to, you can basically just use this computer inside your own computer. We have a web browser. You can go to Wikipedia here. Everything works fine. But we also have a couple things linked in or included in the our systems. So, for example, we have QGIS, and it's also integrated with your home directory in in this in Victor in the cloud. So if I just take Colima here, for example, then load it in, that was right in the DEMs folder that everyone can see. You could do that yourself, and we already get this. And then we can even do a hillshade, and then hold on, it's being a little finicky. Doesn't seem to want to let me press the bottom button. Okay.
But scaling.
Yeah, let me try this. Okay, there we go. Okay, sorry about that. But yeah, you can get a pretty quick, nice hillshade from the existing DMs. You can bring yours in. We have some helper functions we'll show you next week, and you'll practice getting a DEM, but we'll leave that for next time. But In short, we try to make this a kind of completely contained one-stop shop for anything you would need in terms of working with data or models or anything in the field of kind of computational volcanology, whatever subdiscipline you're in. And if we don't have that, let us know. We can either add a model if you know of one, or we can work with you on developing something. We want to make this accessible and useful for as many people as possible in as many disciplines in volcanology as possible. That's, I think, all from me. If you have anything you want me to add, Sylvain, let me know. Otherwise, I can let you take the reins back.
No, that's great. Thanks, Sam. So I guess everybody's almost logged in now. So during the last 10 minutes, I just want you to go through the hub, go through the different tools, explore yourself, and let us know if you have any questions, anything you cannot do, or you're not sure how to do. Please ask it during these last 10 minutes. Whether it's like opening a notebook or something I want to mention is that each time you want to edit a notebook, please copy and paste it in your home directory. That's very important because you cannot actually edit a notebook that is within the shared folder. So please do that each time you wanna even to run a notebook. I would just like copy and paste the notebook. Maybe some you want to show them how to do that quickly. You just right click on the notebook and say copy, and then go into your home directory and paste it inside. So then you can edit it and work on it.
Right. So you can also set folders as favorites, which I find is very nice. So I actually have the workflows folder here, and it'll bring me right to that. Generally, we have, as I mentioned before, we have the Victor setup function, which should set these all up for you. But if for whatever reason we don't have that for that specific model, or you need to copy something else, you just can right-click, copy, go back to whatever folder you want, right-click, paste, and it's right there.
Yeah.
Something for a moment that I wanted to
can you remind me, Sam? Can you remind me how much storage each user have?
Each user right now, I think, has a cap of 20 gigabytes. If you really need more, please let us know ahead of time before you start, because the machine will start running into problems if you try to use more than 20 gigabytes of storage. But we can expand it if you ask us, or if you tell us beforehand. I'll also say, hopefully, within the next couple of weeks, we are trying to make a kind of group folder specifically for this course that you will be able to write files to. We're working with our infrastructure partner who's kind of helping us make sure all this works and stays online 24/7. So we'll keep you updated on that. And we also plan to have some, I don't know if you would call them assignments, Sylvain, but kind of things to take home and explore as well. And we're going to try to use some packages for kind of dispersing those effectively as well. But once that is set up, we'll let you know how to do it. And that's just something to look forward to.
Yeah, if you can show again the directory where the folder where we're gonna mostly work for that short course this semester.
Yeah, sure. Sorry about that.
So that's gonna be the folder where we're gonna
be
put
in
most of the class material.
Yeah, it'll be in shared, then education, and then USF Comp Volc Spring 2026.
Right. So we're gonna make sure you guys know how to access the material, but that's basically the folder we're gonna use to share material. And we're trying to explore ways to do that as a group. So then once you do the activities in the next few weeks, you can actually submit your notebooks as assignments directly on that folder. So hopefully that's going to be a functionality that's going to work. So just a word on the assignments. It's not mandatory. You don't have to do the assignments once we give you some assignments to do for the next week. I totally understand that some of you work in observatories or the structure and don't have time to actually work at home on these assignments. So that's why we're going to try to do most of the thing during the class hour. And then no worries if you don't have time to finish the assignment. For those who want to finish them and have more time, that's great. Try to do them, and then we can give you some feedback on these assignments. But what I wanted to say is that it's not a requirement to actually complete that course, to actually complete these assignments. It's really something that we put in there because we want the course to be more interactive and to have so that you can receive feedback on things that you want to do. So yeah, it's the course is totally modular on that aspect. But don't feel obliged to do the assignments. If you can do them, that's great. If not, no problem. So I think the first assignment for next week will be to explore the hub. Okay, so go in there whenever you have time, logging again, and then go through the different tools. Probably try to, if you can, try to open a notebook in your home folder and run the notebook by clicking on the different cells and clicking on the run button to try to see what do you get at the end of each cell, and then run through all the cells of one notebook towards the end, and also explore the desktop and open the different tools and software that are available on the desktop. And let us know, give us any feedback, things you cannot do, things you have trouble to do, or particular things you would like to do with the hub. Please put that on the Slack channel or come to the office hours next week, and then we'll be able to help you. Okay, so I think that's pretty much it. I don't know if Einat or Sam, you guys want to add something? So we're gonna put all the recordings on the. I'm gonna send you a link to each of the recording today, and then we can also put them on the website. We have a page dedicated to the class on the website, so we're gonna put them there as well.
Do we want to take? It's a little late now, but we let me quickly show the site, all of our websites, and just what they look like.
Okay.
Okay. So if we go to victorproject.org, it's gonna, okay. So this is kind of this is our main website, just for access to things. So you can some general information about Victor. We finally got our first paper published. If you're interested in reading about that, we have a people page. This just links to the hub portal. We also have an education page if you're interested in using this for any of your, if you're an instructor and you want to use this for teaching. So we also have a documentation page or a site, which is docs.victorproject.org, and a long list describing the models we have using the platform, remote sensing, the Victor library, so on. And then I think the only thing I also wanted to show was our YouTube channel, which I think Let me see if I can find this.
Well, you're finding it. I just wanted to add that documentation for each of the models are available, like Victor, like Sam was just showing you. It's super important to read the documentation before you want to use a model, especially if it's a model you never used before. The first step is really to go through the documentation and then click on the model you want to use and read through that documentation, because we can put some text in these notebooks, but you're never going to get the detailed explanation of what the model is doing, how to run the model in the notebooks. There's always going to be some abstract and summary of that. So it's really important that you read the documentation of each of the model you want to use.
I'll just note that we do have a YouTube channel that not only posts the short course a couple of weeks after we initially have it, but we also have kind of tutorials on running specific models, our webinar, let's see, a lot of short course and such presentations, using IMEX, using Zephyr 2, and so on. That's about it. I just wanted to kind of show that was an option. If you have any questions about any part of our platform, please don't hesitate to reach out. So you can either, I know we're going over, you can either email me or this will go to all of us. Here are the 2 emails. So if you have technical questions, just send it directly to me. If you have general questions, you can send it to the Victor at email. That's all for me.
All right. Well, thank you all for joining, and see you next week. Okay. And please explore the hub and put your comments and questions on the Slack channel. Thank you all.